There's a wooden shelf above my computer keyboard where I keep tools that I access quite often, as well as little things to remind me of tasks that I need to complete. These screws remind me that I need to replace the fan in my computer. This 3D printed dial for a potentiometer is something I want to write an article about. And I wanted to make robot wheels out of these possibly racist wooden nickels. But more importantly are the tools. I've got a screwdriver, I've got a pen, I've got a magnifying light, and my favorite tool of all is my LED tester. It consists of a 9-volt battery and a current limiting circuit. In this video, I'm going to tell you a little bit more about how it works and tell you about the successor that I created this year for it. This is my original LED tester tool. I made it about 10 years ago and I use it on a regular basis. And the way it works is you take an LED and you touch it to the pads. If it doesn't light up, you've got the LED backwards, and that's important because before you go and solder this LED into a circuit, you want to make sure you've got it in the right orientation. So if you do have it in the right orientation, it lights up. So there's a pink LED, and there's kind of a teal LED, and a red one. And because these have different colors, they tend to have different voltage drops. But this current limiting circuit makes sure that it supplies the same amount of current to each of the LEDs. So not only can you tell what color they are, but you can tell exactly how bright they'll be in the actual circuit. Although this tool is very useful, it does have some limitations. I normally have it set to 20 milliamps, and if I want to change that, I have to get a little tiny screwdriver, I have to get my multimeter in current measurement mode, pull out this jumper, hook it up, and then try to get the screwdriver onto the little screw, and then the trimmer potentiometer ends up coming off the board, and finally I get the new current set correctly. And then you take your LED and you put your multimeter in volt mode, and you measure the voltage of the LED as it's being lit, and then you take that number and you plug it into a spreadsheet to determine the size of the resistor that you want to use in your circuit. This year I figured, why not have the tool do all that work for you? It's the same basic circuit as before with a current limiter and a 9-volt battery, but now it has an LCD display. And when you place an LED across the pads, it still lights up as before, but now it tells you the voltage drop of the LED, the current that it's consuming, the target voltage of the system that you'd like to wire the LED into, and then the recommended resistor to give you that current at that voltage with that LED. As you place different LEDs on the test pads, you'll notice that the voltage changes. So this red one is using a lot less voltage than the previous one. The teal one is using 3.6, which is about the highest I could find for a standard single LED. Okay, so here's an interesting LED. When I touch it to the pads, it doesn't seem to be lighting up, and it says it's 1.2 volts, which is very, very low. That's because this is an infrared LED. So it's working, it's just that you can't see it with your eyes. I thought, well, okay, so if you've got that, why not try a diode? And once again, you have to do the polarity correctly. Look at that, there's a Schottky diode down all the way at 0.2 volts. If you want to connect the LED to a different target voltage, you turn this dial. And so let's turn it down to 3.3 volts. That would be the size of the resistor that you need to use in order to get this brightness with this current with this LED. Or you can turn it way up, and obviously the resistance value increases in order to keep the current the same. The actual voltage going to the LED does not change, it merely changes the calculation, because that's the target system that you're going to install the LED in. It's not the actual voltage being supplied. The actual voltage being supplied to the LED is right there. Earlier, I talked about how difficult it was to adjust the current on the original LED tester. On the new LED tester, I decided not to use a dial on this potentiometer because I rarely want to change the current and I don't want to brush up against it by accident. So I still am using a screwdriver. So it's not absolutely perfect, but at least now I can adjust it and see the adjustment on the screen rather than having to attach a multimeter. If you are interested in learning more about this test tool, there's a link down below to the schematics, source code, and close-up photos. Thanks for watching.